This is a question from 2022 February-March series, paper variant 1-2 and question 27. This is about the interference of a wave, in fact a sound wave. Now you can see the details over here. An observer is standing at location O and two spots X and Y are the two loudspeakers, could be the sources of sound waves, and they are emitting a sound wave in phase and a wavelength is 0.75 from both the sources X and Y. Now observer can stand anywhere according to the question on a straight line. So right now the observer stands at a point where the sound waves from X and Y meet in phase. This is a very important information, this one. It means the sound traveling from X towards O and the sound traveling from Y towards O is meeting at this location. Both waves are actually meeting in phase, which is called constructive interference. What could be the distance OY and XY? Now first of all, you should remember, I have already written something to save, just cut down the time. Path difference at O must be, for in phase, should be equals to n lambda. Okay, now the path difference is the distance traveled from X towards O and the distance traveled from Y towards O. So apparently, not apparently, obviously YO is greater than XO. So path difference formula would be OY minus OX. OY minus OX, right? And if I divide the lambda, OY minus OX by the lambda, answer must come a whole number. This is a requirement for constructive interference. Whatever the value of OY and OX, if I put down in this formula, wavelength is already given to me, so the answer must come with a whole number. So first of all, OY should be greater. Now look at the options. We have to find out the options like OY and XY key values. Now if you look at XY is this small distance, right? And OY is this large distance. While what we are looking for O2Y and O2X. So obviously it means OY must be greater than XY, and they have mentioned over here OY is smaller. So ये option भी wrong है, this option is also wrong. So the answer could be either C or D. So first of all, I have to find out what the value of OY is given to me in the option 2.75. XY I need to figure it out. How I can find the XY? Now this small distance is written as OY minus OX equals to XY. Now in option we have given XY2, which is smaller than OY, so I can consider the option C. So if I consider option C like this, OY minus XY is equals to OX. OY is 2.75, XY is 2, so the value of OX, the value of OX is coming 0.75. Now put this value in this formula. OY is 2.75 minus OX, which is 0.75, divided by the lambda, which is 0.75. I am getting 2 divided by 0.75, and I can see that from the calculator 0.75 I am getting a number which is not a whole number. It's 2.6666 recurring digit is coming. So it means option C is also incorrect. The only option left is D. So you can stop working, because in the exam the time is very precious for you guys. So like the answer is D now. But for your explanation, let me solve for D as well. For option D, all right, again I am working for OX. For OX 3.25 minus the value of XY, which is 1.5. So 3.25 1.5, 3.25 minus 1.5, I am getting again, I'm getting 1.75. Now formula of N, 2.75 minus 1.75 divided by 0.75, the wavelength. So we are left with 0.75 divided by 0.75, which is 1, and 1 is a whole number, whole integral multiple, and lambda is a whole integral multiple for the constructive interference. So it is proved that right option is D. You got this? Thank you very much.